children, please sit in the top 2 rows. Young children and children for 5 and 6.
Motion-related sensations. Once you find your home, please move all the way into the center seats. It's a very interesting show, a lot of fun. I hope that everyone enjoys it. Remind yourself that you are in fact seated firmly on the Earth's surface and not flying around it. The feeling should pass, and it's wonderful what a few moments of darkness can do for you anyway. Well, it would appear that my timekeeping device is a little bit on the fast side, but that's all right. Just about everyone's found their seats, and that means escape is now difficult. Escape from what, you may ask? Bad science jokes, that's what. And yes, they are bad. How do astronomers organize a party? They plan it. Groans are appropriate responses to these, although I do appreciate the pity laughs and the clapping, I really do. Let's see here. How does Jupiter hold up his pants? An asteroid belt. Yeah. Told you these are bad. Let's see here. How does the moon cut its hair? Eclipse it. Now here's one that I heard from Yoda. Why was 5 afraid of 6? Because 6, 7, 8. Yoda bit's important on that one. It's a little bit of a sleeper. It sneaks up on you. All right, now 6 maybe you're afraid of 7 because 7, 8, 9, but why did 7 eat 9? Because you're supposed to eat 3 squared meals a day. Nothing like a bit of exponentiation humor. I'm gonna go ahead and stop though before people start throwing things. Glad we don't allow food here in the planetarium, otherwise I'd be covered in rotten tomatoes by the end of my shift. Perfect. All right, so the lights are going to dim. Please remain seated while the lights are dark. I still see the glow from a cell phone. Oh, 2 cell phones. If you need help turning them off, feel free to ask the child next to you. All right, one final thing. Once again, my name is Dash. Please sit back, relax, and enjoy Dark Universe.
Astronomers identified pulsating stars like those in our galaxy. By measuring the stars' distances, they found a galaxy in its own right, far outside the Milky Way. The Andromeda Galaxy is more than 2 million light years from us. So we see it as it looked more than 2 million years ago, long before humans first walked the Earth. As they probed deeper and located many more galaxies, the astronomers were startled to see that the light from distant galaxies was always stretched out to longer, redder wavelengths, signifying that they were all moving away from us. They found that the more distant a galaxy, the faster it's moving. Cosmic space is constantly stretching, carrying the galaxies with it. But there's no center to the universe. An observer in this galaxy would see the same evidence of cosmic expansion as we do. So would observers in that one there. Wherever you are, it looks as if you're at the center and everyone else is speeding away. As the universe expands, it cools, its energy thinning out across a growing volume of space. The overall temperature of the cosmos today is only 3 degrees above the coldest possible temperature, absolute zero. But if we ran time backward, all that energy would be compressed into a shrinking volume of space, and the universe would get hotter. Realizing this, a few scientists calculated that the entire universe must have once been hotter than the sun. Skeptics ridiculed the idea, naming it the Big Bang Theory. But then, in 1964, 2 astronomers at Bell Labs in New Jersey started testing a horn-shaped radio antenna. They wanted to detect the natural radio waves produced by gas clouds in space. Instead, they encountered something they couldn't explain. Low-level energy coming evenly from all directions in the sky. Without realizing it, they had made one of the most profound discoveries in human history. Light from the Big Bang itself, released when the universe was only 380,000 years old, less than 1/100th of 1% of its current age. Evidence of the Big Bang was written all across the sky, in the glow of what is now called the cosmic background radiation. Satellites have since mapped the cosmic background radiation in detail, revealing how matter and energy were distributed in the infant universe. In this map, created by the Planck satellite in 2013, the slightly more massive regions are colored blue. Over billions of years, they went on to form clusters of galaxies. The less massive regions, colored red, became cosmic voids. Everything we see in the sky belongs to the past. These spheres mark distances from Earth in light years. When we observe galaxies billions of light years from Earth, we see them as they looked billions of years ago. We're flying through a 3-dimensional atlas of millions of galaxies. The gaps are regions we have yet to map. Beyond every galaxy we could ever observe, farthest away in space and furthest back in time, the cosmic background radiation marks the visible edge of our observable universe. Yet, evidence of what happened even earlier in cosmic history can be found, right in our own neighborhood. 1985, NASA's Galileo spacecraft released a probe to study the upper atmosphere of Jupiter. Scientists had calculated that the simplest atoms were forged during the first minutes of the Big Bang. One of them, heavy hydrogen, is destroyed inside stars, so it should have become ever rarer as the universe evolved. Unlike Earth, Jupiter acts as a cold storage locker, preserving samples of the materials from which the solar system formed more than 4 billion years ago. By analyzing the giant planet's atmosphere, scientists could check how much heavy hydrogen existed back then. Observations of the cosmic background radiation had established that the universe was once hotter than the surface of the sun. Galileo's audacious exploration of Jupiter found enough heavy hydrogen to confirm that during the first minutes of the Big Bang, the entire universe was hotter than the center of the sun. Hot enough to forge simple atoms. But while scientists were piecing together the history of atoms, evidence emerged that most of the matter in the universe isn't made of atoms at all. The universe contains clusters of galaxies, like this one. Each cluster, home to trillions of stars, generates enough gravity to warp the space around it into a giant lens that distorts our view of the galaxies beyond. But when we calculate the strength of these gravitational lenses, we find that each cluster must contain 6 times more matter than we can see there. So now it seems that all of the glowing stars are just the glittering froth on a dark cosmic ocean of invisible stuff called dark matter. The motions of galaxies within each cluster confirm the presence of dark matter. The galaxies orbit too fast to be held together by the gravity of normal matter alone. Remove the dark matter, its lensing stops, and the cluster flies apart. Scientists find that dark matter, shown here in black, was essential to forming the large-scale structure of today's universe.